In this video, what I'll do is I'll show you how to prove that functions are inverses of each other. If functions are inverses of each other, they must undo each other perfectly. So we're going to use our newfound composition of functions to help us do this. So it says if they are inverse functions, then f and g are inverse functions if and only if both their composition functions are the identity function, and the identity function is x. So in the end game, what we want to be able to do to prove that they are or are not inverses are run f of g of x and g of f of x, and if our answer, simplified answer, is just x for both of them, they are inverses. If they are not, then we just simply say they are not inverses of each other. So let's try this. What we want to do is we want to take f of g at x, which means we want to put f of g of x, which means g of x is going to go into function f. So we're going to put an input of x in for g. G is going to do something to it. We want to see if f is going to undo that and bring us back to x. So that means find g or f at 1/3 x plus 4. Well, function f requires us to take 3 times your input and then subtract 3. So we're going to substitute. We're going to put into function f function g. So it's 3 times 1/3 x plus 4 and minus 3. So I'm going to distribute the 3. It's going to be x plus 12 minus 3. And that means we got x plus 9. Now that's as simplified as we can do it, and this does not come out to just an x. So because it doesn't, these are not inverses. So that's how we can prove using a composition of functions that they're not inverses of each other. Okay, now let's take a look at the next example. We've got f of x equals 2x squared minus 1, and we want to prove that it's an inverse to function g of x, which is the square root of x plus 1 all over 2. To prove this algebraically, we run the composition of f of g at x, and we see if we get x. If we do, great, we'll try the next one, g of f at x. If it doesn't, then we'll just stop. So we'll find f at g of x, which means we will put in to function f, which is 2x squared minus 1, what g is. So g of x is kind of an ugly expression. It's the square root of x plus 1 all over 2. But we're going to put that in for the input of f. So it's going to be 2 times the square root of x plus 1 all over 2. That has to get squared and then minus 1. So this equals 2. When we square a square root, they undo each other. So it's going to be x plus 1 all over 2 minus 1. If I keep simplifying this, this is a 2 over 1 times an x plus 1 divided by 2, then minus 1. Well, those 2's will reduce, so we'll be left with an x plus 1 minus 1, and lo and behold, we just get an x. What this tells me is no matter what I put in, no matter what the input is, f will undo whatever g does. Okay, so that's halfway done. Now we've got to come back, and I'm going to clear the board so I have room. If that's true, then we're still in the running for them to be inverses, but we now have to prove that g of f at x is also going to be x. So you have to do both. If it works for the first one, go to the next one. So now we want to put in f at x into function g. Okay, so g is the function that says you have to take the square root of x plus 1 and divide it by 2. And you want to put into function g what function f is, and f was 2x squared minus 1. So that has to go in for the x. So this x is coming out, and we're putting function f into function g. So it's going to be 2x squared minus 1 plus 1 all over 2. So this got put in for x, then we have to add 1 to it, divided by 2. So now I'm in the simplifying stage. It's going to be 2x squared minus 1 plus 1 all over 2. Those parentheses didn't do a whole lot. There's no distributing to do. Well, the plus 1 minus 1 cancel, so that means I forgot my square root sign. The square root of 2x squared all over 2, and the 2's reduced to a 1, which means I've got the square root of x squared, which is just x. Now, for both of my compositions, when I ran f of g at x, it gave us an x, and when we did g of f at x, we got a return value of x, which means they are inverses. And that's how we're supposed to prove or verify that two functions are inverses of each other. good luck with that assignment. The answers are posted as well to help guide you, but hopefully that gives you some direction.